And thanks to the organization for giving me the chance to give this talk here in the last CSSconf edition in this type or whatever. So it's really a pleasure and an honor to be here in this great conference. So the title of my talk is Improving Website Performance with CSS Containment. So quite a long title, it even doesn't fit on the slide. So I will go over it slowly. So first, let's explain a little bit about me. I'm Manuel Rego. I'm part of Igalia Web Platform team. Igalia is an open source consultancy that has a cooperative-like structure. So we have people all around the globe, despite the headquarters are in Spain. And we have a large team working on browsers, and we have been implementing several CSS specifications and other things on browsers. I have been working on grid layout mostly for several years, and also other specs in Blink and WebKit. And now I'm working also in CSS Containment. And as part of all this work, I have been interacting more and more with the CSS working group people, putting issues, participating, discussing, and finally joined the group like 2 years ago. So yeah, the spec, the talk is about CSS Containment. This is a CSS spec. This spec has a property that is called contain, and it has 4 values: layout, paint, size, and style. And that's all, so we are almost done. I mean, it's very simple in theory, but I think it's going to be trickier to explain. Maybe you watched some of my talks about grid layout or read some of my blog posts about it. I mean, grid has tons of properties, many different values for each of them and all that. But I believe it's easier to understand that maybe CSS Containment. So let's see if I manage to do it properly and you don't get very bored. So the other part of the title was improving website performance. So basically, you can improve the performance of a website in many different parts. You can improve how images are loaded or the resources or whatever. In this case, it's more about the rendering pipeline. These are somehow the main phases from a very nice article by Linton Clark. So you have like where you compute the style, you do the layout, where you are positioning the thing, then you paint, then you composite the layers. And basically, with CSS Containment, we are going to be able to get performance benefits in this pipeline. So let's go to the spec. The spec is now candidate recommendation. So it's quite stable at this stage. And we will explain how it works and try to explain the different options and all that. So basically, the main goal of CSS Containment is to improve the performance of a website by identifying the independent parts of a website, which are parts of the DOM tree that doesn't have to interact with the rest, so somehow isolating that subtree from the rest of the page, in a way that if you do modifications inside that subtree, they don't get propagated outside, so you don't need to do work in the ancestors and all that. One confusing thing about containment, when you first read about it or you heard about it, is that it's not that things outside cannot affect the elements inside. It's not top to bottom, but it's the other way around. Things inside that element are not going to affect anything outside. So this is a sentence by Tabakin, one of the spec editors, that he usually needs to repeat over and over in the CSS working group meetings. Like, contain property doesn't block things going into the subtree, it blocks things leaking out. So it's quite relevant for all the containment stuff. So yeah, I already say that this spec only introduces a new property, which name is contain, so it's very easy to remember. And this property has 4 values, main values or types of containments. Layout, paint, size, style, you can just put 1, put 2 combined, or combine the 4. You can do whatever you want there. And style is red in the slides because it's marked as at risk now in the spec, so we will talk more later about that. So imagine this is a website. You have some content, some text, a header, whatever. And you know that you have a component, maybe in the top left corner, for example, that you are showing some live information that you are getting or showing an animation or whatever. But you know that's totally independent from the rest of the page. So you identify that part, mark it like a contained element, and when the browser does work there, it doesn't need to care about the rest of the page. If the page is very big or very complex, DOM tree or whatever, the browser doesn't need to spend any single time in doing other stuff. So basically, what web authors will need to do is to identify which are the independent parts of our website and mark them with a contain property. And then the browser engine needs to do something, because it's not just parse the property and implement the restrictions, but also it needs to implement some optimizations and avoid doing extra work. Browser engines usually try to do as less work as possible when you do a change in a website. They have some kind of heuristics in order to achieve that. But still, there are many corner cases and many combinations of things. So when you do a change in a single element that you believe is not going to affect anything else, the browser still needs to maybe check all the siblings just in case you are overflowing content and you need to paint something in other parts or whatever. And when you use containment, you have some kind of restrictions or implications of using it. So you cannot just put contain to all the elements and you are done. You need to put it when it makes sense. So there are like these 4 types of containments we are going to review. First one, for example, layout containment. Basically here, that means that the internal layout of the isolated subtree is totally isolated from the rest of the tree. So the element where you put contain layout, the layout of that element is totally independent of the ancestors. So these are the effects it takes to that element. Any overflow on that element is treated as sync overflow, like shadows, for example. I will show an example later. That element becomes a containing block for absolute and fixed positioned descendants. It also creates a new stacking context and independent formatting context, like display flow root. And also that the element has no baseline. So why these restrictions when you use it? So let's show an example of this ink overflow thing. We have here two divs, that one has contain node, the other contain layout. Is the magenta dotted border the element that has the contain node or contain layout? So if the size of the text is changing here, you see that an scroll bar is appearing on the parent element. So the browser, something changes inside but needs to do work outside, like painting this scroll bar. But with contain layout, it doesn't need to do anything outside. This is treated as ink overflow, like shadows. You cannot access it actually, but I mean the browser can avoid doing any work in the parents, checking if there are overflow, and it needs to print to show a scroll bar like here. Similar is for baseline. I say that when you use layout containment, the element is considered to have no baseline. So basically it's the same. If here in the contain node, you see that the foo is aligned with the bar. In the other one, it used the synthetic baseline. That's the underlying in this case. If the size changes inside, the browser needs to move foo a little bit below. However, with contain layout, something changes inside, but the browser doesn't care. I mean, it can save time and avoid that kind of operations. So another type of containment is paint containment, which is pretty similar to overflow hidden, but also has some effects. So basically, the descendants cannot be displayed outside of the boundaries of that element. But again, it has some effects. Contents are clipped, like with overflow hidden, but also it becomes the containing block for positioned descendant children. It also creates stacking content and independent formatting context. So let's see another example. So we have contain none, again, in the dotted magenta element, and contain paint. And we have an absolute positioned element that has minus 100 pixels top and left. It has 200 pixels by 200 pixel size. So it's positioned against the parent, meaning it's the viewport or whatever. And in the other case, it's positioned against the container element. It's moved a little bit left and top. And also, the overflowing things are clipped. So when you change the color, here the browser needs to paint also things outside that element. But here, the browser only needs to paint things inside. So again, if you have an element with contain paint that is not in the viewport, the browser can avoid doing work on it, doing any painting, because the browser is sure that there is not something overflowing that is painted in the viewport or whatever, they know that they can save that time. Size containment is about how the browser computes the size of an element. Basically, if you put contain size, it's going to ignore the children. So the element is treated as having no contents, only things like padding at the space or column gap if you have multi-column, or the tracks in grid, something like that you already define, but not the contents itself. And also it's monolithic. That means that you cannot split it when you print it, or it's in multi-column or things like that. So again, this is the same example again. So the first element, the size depends on the contents, this hello world. And when the contents change, the size changes. But in this case, only is the padding, the size that is defining the size of that element. If the contents change, it doesn't care. You see that it's overflowing. The thing is that when you combine this with the other ones, the browser can say, OK, I know for sure that nothing is going to change outside, and even the size is not going to affect anything outside, and all that. And then the last one is style containment. This is somehow special because it only affects counters and quotes. I don't know if you use them a lot. I guess no, because it's not very common, but at least it's on the spec. And it's currently marketed as at risk because the scope is maybe too narrow, only counters and quotes. So there are some discussions about if it's worth. Firefox, for example, is not implementing this so far, so that's another reason why it's at risk in the spec, because they don't see the benefit. And also, Chromium implementation of style containment is pretty broken, so it only works for the very simple cases. So if any of you find a use case that can get performance benefit with style containment, share with the CSS working group and the GitHub repository, because that will be valuable information to know if we need to keep or not this value. So basically, the effects are that the counters and quotes are scoped to the subtree, and that when you try to increment a counter, you actually are creating a new one instead of incrementing it. So basically, there's an example with counters. This is a class that is incrementing this counter n, and this is just an element that paints the counters. So we are here creating this counter n and incrementing to 1. Then we print it, it's just 1. Then we have a contain style element. So this counter inside cannot increment the one outside, so it creates a new one. So we have here 1.1. And when we print it after outside of the contained element, this doesn't know anything of what's happening inside with the counter. So that was isolated, so it's still 1 again. So that will be the expected output. Then with quotes are, I think, even a less common use case. So you can define which symbols are you using when you have nested quotes. So this is double first and then single or whatever. And then we are opening a quote here. We have foo. Then we have the style containment element, and we open another quote. We have the text bar, and then we close the quote. When we close this, it doesn't know that a new one was opened inside the style containment element. So it just closed the open. We are not closing both in this case, but I mean, basically that the changes here doesn't affect anything outside. So, OK, we have aliases in the spec. So you can say contain content, and that implies layout and paint. Or you can say contain strict, and that implies layout, paint, and size. This used to include style too, but like style is marketed at risk, and Firefox was planning to ship CSS containment. It was removed from the spec at this stage. If in the future style is implemented by all the browsers, probably there will be a new alias like all or whatever that will include the style too. So let's check the status of things. This is not a new spec. Maybe it's the first time you heard about it, but it has been shipping for 3 years already in Chromium, so it's not a new spec at all. And Google has been using it in their products, like YouTube or Gmail, even in the Chrome DevTools, things like that. But during the past year, there has been quite a lot of work in the spec. Florian Rival, one of the spec editors, has been working quite a lot and pushing the spec to candidate recommendation. Also, the test suite in Web Platform Test repository has been completed by Gerald Talbot and with contributions from Mozilla and Chromium, like while we were working in the implementations. We at Igalia have been fixing the implementation in Chromium, so it's aligned with the spec, and we can start to implement optimization based on that. And that was causing us to be breaking most of these sites. I mean, we broke YouTube for a while, we broke Gmail, we broke DevTools several times because maybe they were using contain layout, for example, in many places, and now the overflow is treated as sync overflow, so you cannot access it, things like that. Or now that is a containing block for the position and descendants, so everything is positioned wrongly. So you need to or stop using contain layout or change how things work inside that element. And then Firefox is also working on implementation. They are targeting Firefox 69 to ship it, but you can already test it behind the runtime flag. And meanwhile, Chromium has been implementing some optimizations based on CSS Contain. So, like I said, you can just parse the property in the browser, implement the restrictions, and you are like passing all the tests of CSS Containment, so you are totally spec compliant. But maybe you don't have any optimization in the browser, so it's not useful at all at the end. So then when the browser has that information, it needs to still implement some optimizations. And if we look at can I use, like Microsoft is moving to Chromium Link, it's getting support for this, all the Chromium browsers have support for this. And Firefox is about to ship in a few releases. And then regarding Safari or WebKit, there are no public signals yet. So let's show some examples to try to understand this a little bit better. This is one example from a blog post I published about containment. Is very simple and not cool at all, but I believe it's the best one to understand how it works. So imagine that we have a very dumb tree, like 10,000 elements like this item that has, all of them have one child, and we are modifying the content of that child over and over or whatever. So we have a DOM tree like this. We have many, many elements here, but we are only doing changes in this green div. But still, the browser needs to do work in the rest. Not out of work maybe just traversing the whole DOM tree to do some checks or whatever, but it's doing work on all of them. So if we can say, OK, this has contain a string, we cannot affect anything outside. We are just changing things inside here. The browser can avoid navigating the rest of the things. So this example is, not cool at all. It's changing the text in the first element. And it actually goes from changing it's taking 6 milliseconds without containment to take 0.2 milliseconds with contain strict. So it's like quite a big difference. This is another example. It's the same one, but I'm using real layout in the items because I know that real layout has all these track sizing algorithms, so it's somehow costly if we think about performance, so it takes a while. And on the left, we have Chromium. On the right, we have Firefox. That's because I was crafting this example for this talk, and I realized that we were not getting very good results in Chromium, so I was checking Firefox, and Firefox was much better. And it makes actually sense, the results we are getting in Firefox. For example, with these 10,000 items, in Chromium is like 12 times faster with contain strict. That is quite a lot, but in Firefox it's like 2,700 faster. But that makes sense, because if you need to visit 10,000 grid containers and do layout on each of them and all that, or whatever you need to do, instead of just doing it in one, it's expected that it's very, very fast when you just have the strict containment in that element and you just do it there. So we have been working on this at Igalia as part of our ongoing collaboration with Bloomberg, in which we implemented CSS real layout in the past years, or we have been implementing things in JavaScript like async await or begin lately or whatever. And Bloomberg has some quite complex UIs, and they were getting benefit of using CSS containment in some of them. So this is one of the stress cases we had. This is like a huge table-like layout or grid-like layout. It doesn't have to be a table or a grid, it doesn't matter. But it has like 10,000 cells or whatever, and the text is changing constantly. But we actually know that we are just changing one number by another one there, by another number, that the number is going to fit in the size we are providing. We know that for sure. So we don't need, we can say to the browser, OK, this element has contain layout size, and you can avoid doing the layout of the text you are changing there, because if you're adding a long sentence or whatever, the browser needs to do line breaking, all that, and calculate some things. So we are saying, OK, you can save all that time if we have contain layout size, because we know that we are just changing one number by another, and it's going to fit inside. And then this is stress test with 10,000 elements. We were like 4 times faster using containment. So it's nice optimization. This is still to be ported to layout NG, which is the new thing that Chromium is shipping really soon. So there will be like similar things. This was another one, pretty similar again. Very big table or whatever. Here, some of the progress bars are moving, are changing size. We aren't changing the context like that, but something is changing size inside each of them. But the thing is that in the use case, each of these cells was absolute positioner, so we have like each of them has its own layer. So the browser, when something was changing inside one, it was traversing the whole layer tree. And depending on the size of the DOM, that was taking a while in some phases. And then with contain strict and a very big stress test, we get like 10% faster. It's not a lot, but it's, I mean, everything helps. Probably we were expecting more, but maybe there are room for more things yet. So let's talk about the future of all this. We can expect better browser support. Firefox is shipping really soon. We don't know Safari, but we hope that, I mean, we never heard complaints from Apple about this spec, so it seems maybe at some point they will have it. Other thing that we can expect is more optimization based on CSS Contain. Basically, when people start to use it, they will say, OK, like this example I just did in Chromium. OK, this will be much faster than what we are seeing. I mean, I'm changing just one element. It should be almost as faster as having just one element in the DOM, despite I have a DOM of 10,000 elements or whatever. So you can report a bug, and probably the browser will try to improve that use case with some optimization, because maybe, I mean, this is somehow, it's not new because it has been there for a while, but there has not been a lot of work, so there are still a lot of room for improvement here and a lot of optimizations to be done in the browser. And also there are some new features that, or proposals that some browsers are working on that are based on this spec. So I don't know if you have heard about display locking proposal from Google. Google is experimenting with this and have some experimental implementation already in Chromium. Main idea of this display locking is that in a DOM tree, you can lock an element of the DOM. Then you do manipulation in JavaScript. You modify whatever you need there without blocking the main thread, and then when everything is ready, you unlock it and show it in the screen. But for that, you need that that element is independent of the rest, and that's where containment comes to the rescue. And I mean, you mark that element with contain, and then you can do that. So things like this will, I mean, like in the future will appear. Maybe display locking is not the feature that is finally standardized, but it's one of these ideas. And that's all from my side. I hope you understand a little bit better now what this spec is about. You can start to experiment with it and report bugs about it. In my blog, you can read, I mean, I just only have one article about this, but maybe in the future I will have more. I have been writing articles about grid and things we are working on for a while. And I will be around the whole day. Feel free to talk to me about CSS Containment, CSS Grid, how it takes to implement a CSS spec in a browser or things like that, or even asking me about Igali and the things we do. So that's all. Thank you.